Hello friends, in this session I am going to explain about the Thevenin theorem. In this session I am going to explain about the Thevenin theorem, statement and how to solve the problems on the Thevenin theorem. The Thevenin theorem is a very important role to play in an electronics and the network theorem. Yes, first we are going to study about the statement of the theorem is Thevenin theorem. Thevenin is the name of the scientist. Theorem, what he has proved about in the network. Right. Statement. Any two terminals linear network containing energy sources and the resistors can be replaced with an equivalent circuit consisting of a voltage source E0 in the series with the resistor RTH. The value of the E0 is the open circuit voltage between the terminals of the network, and RTH is the resistance measured between the terminals with all energy sources eliminated. The statement is correct. What I have read it. But how to understand the way of that one sentences? Any two terminals linear network. This is a two terminals. Right. Energy sources and resistors can be replaced with an equivalent circuit. Means what ಹೇಳಿದ್ದಾರೆ ಅವರು ಎನರ್ಜಿ ಸೋರ್ಸಸ್ ಮತ್ತೆ ರೆಸಿಸ್ಟೆನ್ಸ್ ನ ಕ್ಯಾನ್ ಬಿ ರಿಪ್ಲೇಸ್ಡ್ ವಿತ್ ಅನ್ ಇಕ್ವಿವ್ಯಾಲೆಂಟ್ ಸರ್ಕ್ಯೂಟ್. ವಿ ಹ್ಯಾವ್ ಟು ಡೂ ದ್ಯಾಟ್ ಒನ್ ಸರ್ಕ್ಯೂಟ್ ಕನ್ಸಿಸ್ಟಿಂಗ್ ಆಫ್ ಅ ವೋಲ್ಟೇಜ್ ಸೋರ್ಸ್ E0 ಅಂತ E0 ಕಂಡುಹಿಡಿ ಅಂತ ಹೇಳಿದ್ದಾರೆ. E0 ಮತ್ತು RTH ಕಂಡುಹಿಡಿದು ಅದನ್ನ ಸೀರೀಸಲ್ಲಿ ಕನೆಕ್ಟ್ ಮಾಡಿದಾಗ ನಮಗೇನಾಗುತ್ತೆ, ಥೆವೆನಿನ್ ಇಕ್ವಿವ್ಯಾಲೆಂಟ್ ಸರ್ಕ್ಯೂಟ್ ವಿ ವಿಲ್ ಗೆಟ್ ಇಟ್. ರೈಟ್. How to calculate the value of E means in the further proof we can identify that just the simple way I am explaining. Series with the resistors RTH, the value of the E0 is the open circuit voltage between the terminals of the network. ಏನಂತ ಹೇಳಿದ್ದಾರೆ ಅವರು, E0 is the open circuit voltage between the terminals. Means this one is your EMF. R1 and R2 is the series, and the E0 is equals to remove the load resistance, we can get the E0 value. Next, RTH is the resistance of measured in the find out the RTH value R1 and R2 to remove the voltage source. The resistance measured between the terminals with all energy sources eliminated the energy sources, we can find the RTH value. Right. Next, after getting the RTH value and E0 value, we are getting the series. E0 is series with the RTH with the load resistance RL. We can get the equivalent circuit. First we have to take the proof of the finding the Thevenin equivalent circuit. Step 1, to draw the circuit. This one is your circuit. Next, we are going to study about the proof of the theorem. Yes, proof of the theorem is ಅಂದರೆ ಟೂ ಟರ್ಮಿನಲ್ಸ್ ಇರೋ ಅಂಥ ನೆಟ್ವರ್ಕ್ ಅಂತ ತಗೊಂಡು ಅದನ್ನ ಏನು ಮಾಡಬೇಕು, ಫಸ್ಟಿಗೆ E0 ಕಂಡುಹಿಡಿಬೇಕಂದ್ರೆ ಲೋಡ್ ರೆಸಿಸ್ಟೆನ್ಸ್ ತೆಗಿಬೇಕು. RTH ಕಂಡುಹಿಡಿಬೇಕಾದ್ರೆ ವೋಲ್ಟೇಜ್ ಸೋರ್ಸ್ನ ರಿಮೂವ್ ಮಾಡಬೇಕು. ಓಕೆ, ಪ್ರೂಫ್ ಆಫ್ ದಿ ಥಿಯರಮ್. ಐ ಆಮ್ ಗೋಯಿಂಗ್ ಟು ಟೇಕ್ ಅ ಸಿಂಗಲ್ R1, R2. And this one is your R3 and this one is your RL. Right? Yes. Next, apply KVL to loop 1. This one is your current I1. This one is current IL. E is a EMF. First R1 I1 plus R2 into I1 minus IL equals to E. Yes, this one is your equation. Means we have to simplify. I1 equals to R1 plus R2 minus R2 IL equals to E. Equation 1. I1 R1 R2 common, I1 minus IL equals to E. EMF. Apply KVL to loop 2. Correct? R3 IL plus, this one is a load resistance, RL IL plus R2 into IL minus I1 equals to, there is no any voltage source, equals to 0. Now we can IL equals to R2 plus R3 plus RL minus I1 R2 equals to 0. Equation 2. By equation 2, find the value of I1 IL R2 plus R3 plus RL equals to I1 R2. I1 equals to R2 divided by, I1 equals to R2 plus R3 plus RL into IL divided by R2. Equation 3. Substitute equation 3 in equation 1. I1 ವ್ಯಾಲ್ಯೂನ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡ್ತೀರಾ. IL R2 plus R3 plus RL divided by R2 R1 plus R2 minus R2 IL equals to E. Take the LCM and take the common of the IL. Multiply those. R1 R2 R1 R3 R2 RL R1 RL R2 square R3 R2 RL R2 minus, take the LCM R2 square. This denominator goes to numerator. E R2. ಇವಾಗ ಡಿವೈಡ್ ಮಾಡ್ತಾ ಹೋಗ್ತೀರಾ. This R3 and this R3. This R2 get cancels. R3 common. R1 plus R2. This RL and this RL makes common. R1 plus R2. R1 plus R1 R2 equals to E R2 into IL. IL equals to E R2 divided by R3 R1 plus R2 RL plus R2 R1 R2. Right? Divided by R1 plus R2. ಏನಕ್ಕೆ ಅಂದರೆ ನಂಗೆ ಇಕ್ವೇಷನ್ ಸಿಂಪ್ಲಿಫಿಕೇಷನ್ಗೆ ಹೆಲ್ಪ್ ಆಗಲಿ ಅಂತ E R2 divided by R1 plus R2 divided by R3 plus RL plus R1 R2 divided by R1 plus R2. Right? Now we can find out the value of VTH. Now we can find out the value of VTH. Right? ಈ ಈಕ್ವೇಷನ್ನ ಹಾಗೆ ಇಡ್ತೀನಿ. ಮತ್ತೊಂದು ಸತಿ ರೀರೈಟ್ ಮಾಡ್ಕೋತೀನಿ. R3 R1 R2 divided by R1 plus R2 plus RL. Equation number 4 ಅಂತ ತಗೊಳ್ತೀನಿ. ಕರೆಕ್ಟ್. ಇಕ್ವೇಷನ್ ನಂಬರ್ 4 ಅಂತ ತಗೊಂಡು ಇವಾಗ ಏನು ಮಾಡ್ತೀನಿ ಅಂದರೆ ಓಪನ್ ಸರ್ಕ್ಯೂಟ್ ವೋಲ್ಟೇಜ್ ಸ್ಟೆಪ್ 2 ಇದು. ಓಪನ್ ಸರ್ಕ್ಯೂಟ್ voltage between the terminal Thevenin voltage. R1 R2 R3. What we have to do, Thevenin voltage ಕಂಡುಹಿಡಿಬೇಕಂದ್ರೆ RL ನ ರಿಮೂವ್ ಮಾಡಬೇಕು. That is your E0. By applying voltage divider rule. ನೀವು ಕರೆಂಟ್ ಡಿವೈಡರ್ ರೂಲ್ನ ಸೂಪರ್ ಪೊಸಿಷನ್ ಥಿಯರಮ್ ಕಂಡುಹಿಡಿಬೇಕಾದ್ರೆ ಆ ವಿಡಿಯೋ ನೋಡಿದರೆ ನಿಮಗೆ ಗೊತ್ತಾಗುತ್ತೆ. ಅದರಲ್ಲಿ ನಾನು ಕರೆಂಟ್ ಡಿವೈಡರ್ ರೂಲ್ ಅಂತ ಮಾಡಿದ್ದೀನಿ. ಇಲ್ಲಿ ವೋಲ್ಟೇಜ್ ಡಿವೈಡರ್ ರೂಲ್ ಸೇಮ್. ಇದಕ್ಕೆ ಏನಾಗುತ್ತೆ, ಅಪೋಸಿಟ್ ರೆಜಿಸ್ಟರ್ ಬರ್ತದೆ. ಅಪೋಸಿಟ್ ರೆಜಿಸ್ಟರ್ ಪ್ಲಸ್ ಕರೆಂಟ್ ರೆಜಿಸ್ಟರ್ ಅನ್ನೋ ಫಾರ್ಮುಲಾ ಹಾಕ್ತೀವಿ. E0 equals to E into multiply by voltage, right? ಹಾಕ್ತೀವಿ. E into opposite resistor is R2, current resistor is R1 plus R2. That is your E0. This is called as a Thevenin voltage. Now you have to find out about the step 3 to find the RTH value. RTH ವ್ಯಾಲ್ಯೂ ಮಾಡಬೇಕಾದ್ರೆ ಏನು ರಿಮೂವ್ ಮಾಡಬೇಕು? ವೋಲ್ಟೇಜ್ ಸೋರ್ಸ್ನ ರಿಮೂವ್ ಮಾಡಬೇಕು. R1 R2 R3. Without load we can find out that one. Open circuit, that is RTH equals to open circuit or obviously R1 parallel to R2 plus R3 equals to R1 R2 divided by R1 plus R2 plus R3. That is your RTH. Substitute equation 5 and 6. Substitute equation 5 and 6 in equation 4. IL equals to current, Thevenin current equals to ER2 divided by R1 plus R2 E0 RTH plus RL. This is your Thevenin equivalent circuit. E0 is series with the Thevenin voltage. ಇನ್ನು E0ನ VTH ಅಂತಲೂ ತಗೋತೀವಿ. RTH with the load resistance RL. This is your circuit. E0 equals to VTH. We can take it. Name. E0 is series with the Thevenin resistance RL with the load RL. This is your proof of the Thevenin theorem. Next we are going to study about the problems on the Thevenin theorem. Problems on the Thevenin theorem. We are again going to take a single example. This is your statement. This one is your problem. "20 volt, 1 kilo ohm, 1 kilo ohm, 1 kilo ohm." First, find the RL. They have not given. We have to take that. First step 1, to remove the load resistance. Now we have to find out the E0 value. E is 20 volt. By applying voltage divider rule, E0 equals to E divided by. Now we have to find out about this resistor, R3 divided by R1, R2 plus R3. Sorry, R1 plus R3. This one is your opposite. 20 into 1 kilo ohm, 1 plus 1, 2 kilo ohm, 10 volt of the E0 or a VTH. Next, find out the RTH value. To remove the source, 1 kilo ohm, 1 kilo ohm, 1 kilo ohm. 1 is parallel to 1 plus 1. 1 into 1 divided by 2 plus 1. 1.5 kilo ohm is a RTH equivalent. 1.5 kilo ohm. E0 is 10 volt. This one is your equivalent circuit. Right? Next problem, we are going to study about the next problem. Find the Thevenin equivalent circuit. Right? "40 ohm, 20 ohm, 60 ohm across 20 ohm resistor." Here across 1 kilo ohm resistor. Right? Resistor EMF is 120 with the load resistance. RL equals to 10 ohm. First, step 1, find the VTH or E0. ಏನು ಮಾಡಬೇಕು, ಲೋಡನ್ನು ತೆಗಿಬೇಕು. ಈ ಈಕ್ವಿವ್ಯಾಲೆಂಟ್ ಸರ್ಕ್ಯೂಟ್ನ ಹಿಂಗೂ ಮಾಡ್ಕೋಬೇಕು. IL equals to E0 divided by RTH plus RL. 10 divided by 1.5. RL they have not given. Write the RL. Here we have to find out the 40 ohm, 20 ohm and 60 ohm open circuit. E naught equals to 120 volt. V naught ಕಂಡುಹಿಡಿತೀರಾ ಈಗ ವೋಲ್ಟೇಜ್ ಡಿವೈಡರ್ ರೂಲ್ನ ಅಪ್ಲೈ ಮಾಡ್ತೀರಾ E naught equals to E into 2 divided by R1 plus R2 120 into R2 is 20 ohm 20 plus 40 60 inside 2 is a E naught equals to 40 volt. RTH value, remove a voltage source RTH 40 ohm 20 ohm 60 ohm. RTH equals to 40 parallel to 20 plus 60 3 ones are 3 threes are 73.33 ohm. Equivalent circuit 73.33 40 volt. Load resistance RL is 10 ohm. IL equals to 40 divided by 73.33 plus 10. IL equals to calculator 40 divided by 83 point 0.48 ampere of current, right? This one is an example. One more example I am going to take, that one, that is a bigger circuit. With the two sources of current source and the voltage source. Five ohm, 10 ohm and 10 ohm. Right. To find the VTH value, we have to remove this current. Correct. ಅಂತ ನಾವು ಹೇಳ್ತೀವಿ, but we are not going to remove that one. That was VTH value. First we are going to take the equation for that one to find out the V1 value, right? That is a 20 volt. This one is a load resistance RL. Right. First we have to remove the load resistance and find out the values. 10 ohm, 5 ohm, 10 ohm, plus and minus 20 volt. This one is a current 4 amperes. ಇದರಲ್ಲಿ ಏನು ಮಾಡಬೇಕಂದ್ರೆ ವೋಲ್ಟೇಜ್ ಡಿವೈಡರ್ ರೂಲ್ನೇ ಅಪ್ಲೈ ಮಾಡಿ V1 we have to take that one minus 20 volt. Current we have to measure that one divided by 5 ohms of resistor. Right. Apply KVL node. Node rules. V1 minus 20 ಮಾಡ್ತೀವಿ, divided by 5 ಅಂತ ಮಾಡ್ತೀವಿ, plus V1 divided by 10 ohm resistor. This one minus 4 ohm current. Why? Because of the current is flowing in this direction, in this direction. right? Minus V1, here it is only apply for that one, equals to 0. Find out the V1 minus 20 into 2 into 4 is a LCM, plus V1 minus 40 equals to 0. Right? V1 equals to 80 to 3 V1. V1 equals to 80 divided by 3. Right? That is your V1 value. V10 value is, calculate the one more V1 of that one. Sorry for that one. V1 divided by minus 20. Current is flowing in this direction. V1 minus 20 by 5 plus V1 by 20. ಈ ರೆಜಿಸ್ಟರ್ನ ತಗೊಂಡ್ವಿ. ಈ ಕರೆಂಟಿಗೆ ಅಪ್ಲೈ ಮಾಡಿದ್ವಿ. ಇವಾಗ ಈ ರೆಜಿಸ್ಟರ್ದ V1 V10 we have to find out that one. 4 into 10 ಅಂದರೆ I into R ಆಯ್ತಾ, that is your V ಆಯ್ತಾ, that is I, this one is a register R. I into R equals to V. V10 value is 40 volt. ಹೌದಾ? Next what we have to do that one, V1 plus V10 equals to VTH or a E0. 40 plus 80 by 3 equals to 240 plus 80 plus 3. 240, 60, 320 divided by 3. 3 ones are 0. 106.66 volt. That is VTH. Now we are going to study about the RTH value. Remove the current. RTH 5 ohm, 10 ohm, 10 ohm. Right? What will you get that one? 5 is parallel to 10 plus 10 equals to 50 by 15 plus 10 equals to 150. 200 divided by 15. 40. 3 ones are 13.33 ohm. The equivalent circuit is 106.66 volt, 13.33. RL is 20 volt, 20 ohm. IL equals to 106.66 divided by 13.33 plus 20. IL equals to 106 divided by 33.33 equals to 3.18 amps. Right? That is your current. In the next section I am going to explain about the Norton's theorem. Yes, with the example I will explain it. Thank you so much for this. Please subscribe our channel. You can get the everyday videos, you can get it very easily. Okay, thank you.